Okay, guys. So, welcome back. I know it's been a crazy week, and I hope you're as looking forward to coming back to math as I am to having you back. I'm going to try to make it sure I keep an eye on my time to make sure this doesn't cut off. I might have to do this in a couple consecutive videos this way until I figure out something better. But we're going to get started and see how far we go. So, today we're going to start Module 5, Lesson 5. So far in math, we have been exploring volume. We've been using our cubes to build structures, and so far, our learning has taught us that however many blocks we have of these cubic centimeter blocks, however many we have, that is how many, what our volume is. So in this case, we have 3 cubic centimeter blocks, so the volume of this shape would be 3. If I take and add 3 more blocks, I have that layer of 3, and then I add a second block or a second row, and now the volume of my shape is 6. In lesson 4, we expanded our thinking and we learned that you can find the volume, or I'm sorry, the area of the base. So remember, area is length times width. So we have 3 times 2. That would give me a base of 6. And if I put 2 levels on it, that would be 6 times 2, because that would be how high it is. I want you to think of height as how many layers. And so now my volume would be 12. All right, I have a layer of 6 and a layer of 6. 6 plus 6 is 12. So in lesson 4, we learned that you can also take that volume, and without using cubes, you can multiply the length times the width times the height of a structure, and that will give you the volume. So if you remember, area is length times width. And so now you find the area of a layer, and then you simply count how many layers there are and multiply by that, and that is going to give you our volume. So let's go ahead and get started on today's lesson. And today we are going to start, I'm sorry, I didn't even go over the objective today. Today's objective is to use multiplication to connect volume as packing with volume as filling. Okay, that's a little bit confusing. I want you to think of it as so far we have been packing the cubic centimeter blocks, but today we're going to be filling. Now, if you remember when we first started talking about volume, I showed you that volume most often comes in liquid containers. We measure liquid in volume. And so as of the moment, we've been measuring with these cubes, we've been packing them into shapes, but today we're going to make that transition from packing them into shapes into filling them. Okay, so nothing's really going to change other than just kind of we're going to add to our schema and grow our understanding. All right, so today we're going to start by investigating. So far we have been using these 1 cubic centimeter cubes, okay? And so everything that we have been measuring so far, when we put our volume, it's always been in cubic centimeters. So for example, if I had a cube and there were 2 layers. So my height was 2. My width was 3. We'll say that this was 3. And then back this way, the length was 2. I would say 3 times 2 times 2 equals 12 cubic centimeters. So since we're going to start making that transition to working with liquid, today I want you to think about the idea that one of these blocks is the same thing as 1 milliliter. So you might be wondering about milliliters. So I'm going to come back to our water bottle. And if you notice, my water bottle is filled, in fact, with 500 milliliters. So that means that if this were a nice like rectangular prism where everything was flat but it was all the same size, that means that I should be able to put 500 of these little blocks in here and that would fill it to the top. But that's not exactly feasible because if you look, the bottoms are all bumpy. It's a cylinder, so it's curved on the sides. So we're going to kind of do that experiment. But instead of using my water bottle, we're going to start with a cube. All right, so I have a cube that's packed here. Now, I have to give you a disclaimer. These containers are really, really tight. So I cannot fill it all the way to the edge without busting the seams here because this is so thick. But I did get one. I forced one in there for you to see that really this whole thing would be filled. So I'm going to go ahead and kind of do a little bit of coloring here. So we're going to count those as blocks. So if I wanted to find the volume of this shape, I would start by finding the length times the width. So I want to find the area. So when I count the area, I have 1, 2, 3, 4, 5, and 6. So my number this way would be 6 centimeters. Okay? 6 cubic centimeters. Now, when I come back this way, I have 1, 2, 3, 4, 5, and I should, if this glass wasn't so thick, I would be able to get a 6th one in there. Which, if you make sense, or if you think about it, that makes sense because this is a square, so all of the sides should be the same length. So that would be 6 centimeters, that would be 6 centimeters. So our area of one of these layers would be 6 times 6. And since, whoops, forgot my centimeters, forgot my unit there. So that would give me 36 centimeters squared. I've multiplied the length and the width. Now, with our new schema, we know that in order to find out the volume, I have to count how tall it is. So when I flip it up on its side, you can see that I have 2 layers here. So when I take that 36 times 2, I get 72